Thank you everyone for being here today, and thank you for attending this PowerCast. IFS Security, don't leave your server vulnerable. This PowerCast is sponsored by Fortra. My name is Peter Casper, Education Manager for Common. If you experience technical issues during the presentation, please go ahead and use the Q&A area. I will get back to you as soon as possible. If you would like to send a written question to the presenter during this presentation, please use the Q&A area also. The presenter will answer your questions at the end of the presentation as time permits. Once again, presenting today is Sandy Moore. Sandy has been working with Fortra customers for over 20 years supporting systems, monitoring, and security software. With experience on IBM I, AIX, and Linux, she has been involved in product demonstrations, implementation, support, training, research, and product testing. Sandy is also a certified professional forensic analyst, a certified data privacy practitioner, and a secured cloud computing practitioner. In her time at Fortra, Sandy has helped customers understand how to effectively address the threats they face. Her goal is to help people achieve the best solution to their IT problems, no matter how many servers are in their environment or where in the world they're located. With that, I will go ahead and hand control over to Sandy. Please go ahead.
Thanks, Peter. Excited to be here today. And thank you for that introduction. I'm also a IBM champion this year too, so that's kind of exciting. I need to add that to my bio. I think it's pretty cool. So wear a lot of hats. Really, security is where I love to spend my time, and hopefully I'll be able to share some good information with you today. So we'll dive right in. Fortra, of course, we've invested in security for IBM I through our PowerTech brand. It's globally recognized. We have comprehensive IBM I security services. We're a member of the PCI Security Standards Council, so keeping a handle on and understanding of changes in the requirements there, as well as our annual State of IBM I Security Study. And it's some insight that we share every year that comes from actual customer systems. And it does help to drive what we do and what I present on. So really, that's what we're going to bring to the table here. Of course, our conversation today is all about the IFS. So the IFS is can be confusing. It's something that I hope everybody knows what it is. I've heard some different interpretations of it. So I thought I would look around and see if I could find a good definition, and Googled it, Wikipedia, all of this, and I found the best definition was actually from IBM. So it's really focused on that integration, and IBM I, that I for integration, right? So the integrated file system, by definition, is part of the operating system that supports all of that stream input output. Storage management similar to personal computer, right? Or PCs we're signing into this meeting from, and the Unix operating system. And what it's going to be doing is giving you an integrating structure over all information stored in the system. And I'm gonna emphasize that there, and we're gonna come back to that later on. If you're interested in looking at that more, I actually pulled this from 7.6. So it's not new, the integrated file system. I just felt that it was made sense to pull it from the most current information. So IFS actually, as I said, it's not new. It's been around since 1994, and it was introduced at 3.1. And what it's doing is integrating that IBM I, giving that infrastructure to allow for Unix, Windows, and other operating systems to interact with the IBM I through a directory structure, much like you would see on a PC. And it's going to give access for that data that's stored on those servers and other IBM I servers, making that integration pretty seamless. But it does have a couple of predefined file systems that is going to come with that, including the root directory, which you guys have probably heard of, root. And then there are some other directories under that that have some specific limitations and rules that we'll talk a little bit about. When we look at the IFS, it's not actually a a bolt-on. It's not an add-on to the existing file structure, but it does actually encompass all of your system as IBM defined it as well. qsys.lib is a folder under root. That is your native system. And this is well before the IFS was introduced, and then also QDLS. Probably going, QDLS, that's old. I still talk to companies who are using QDLS. It's been in place for 40 years. This is how they've always done things. They can't get out of it. So that is still a used structure. Even though it does predate the IFS, it is tied to it and appears to be part of it. Now, things that I do hear too is that people don't use the IFS, and there's always the folks that are not IBMI people who don't even know how it's pronounced, the order of the words. I do hear, and it's not a joke, it's real, the ISF. So it is in fact you can't, it's unavoidable to use it, right? So because it does encompass the entire system with that qsys.lib file structure, you can't not use the IFS, but there's other ways you can use it outside of that native interface. So you're going to have net server, which is going to be that explorer access to the IFS, that you're going to be able to access the system that way, which is what I think most of us think of. But there can be image catalogs on the system that's going to allow for unattended installations upgrades. You're going to have your PACE environment, which is going to support those Unix applications for that integration, right? Client access and navigator executables, those are going to be in the IFS as well. If you've ever noticed, there's a QIBM directory, there's some other folders under that. Your HTTP servers are going to be there as well. So Tomcat application servers, WebSphere, digital certificate manager, even your TCP/IP configuration files, that QTC PTMM directory, right? So the IFS is not usable. So this is something that is critical part of the system, and it is heavily used, even if you don't have what we usually the first thought is, well, we don't let people map a drive to it. And that's not all it's used for. One of the things I like to talk about is that it's if you have any graphical representation of your system, in other words, you're connecting to your system from a PC, even if you're using the green screen, you're using some of the IFS. It's unavoidable. And quite honestly, there's really not a lot of folks with dumb terminals in place still, but there are a few. I got to put my hands on one at Tech Exchange in Florida in October last month. So that was kind of cool, but it's not the most common use anymore. One of the things that we're talking about, of course, is to make sure that these servers are not being left vulnerable through the lack of security over the IFS. And one of the concerns is that, the public access, right? So public authority is not necessarily locked down to begin with on the system. And so that's really why we got to kind of think about, okay, what could be the potential exposure there? Your native objects are going to be changed, and your IFS root folders can have the RWX and the object authorities. So basically all. So that might be a problem if somebody's able to access it. So we need to think about how is that going to happen. When we look at the combination of users that have too much access, and we look at the default authorities on things, we say, all right, well, my employees aren't going to do things that are not appropriate, right? They've been here forever. This guy is our employee for ages. I pick on Bob. I hate to pick on Bob, but Bob's a good name. Now Bob's even bigger name because of Bob for development. But what's happened is that these organizations are placing a lot of trust in these people that have access to the servers. They've had it for ages, and they have entirely too much authority with the assumption that they're not going to take advantage of it. And unfortunately, that's not always the case. There is, in fact, that potential for someone to take advantage of it. And when we see that, those authorized users really are not that far off the mark. And when we look at our state of IBMI security study, these users that have access to the system are going to have special authorities, right? So all object authority, that root, all access pass to the system, which is really hard to stop in most cases. There are some additional controls you can put into place to contain that all object authority, not necessarily get rid of it, but put some guardrails around it. But the idea behind assuming our users don't know how to do things or can't do things is really just relying on security by obscurity. And with that, we've got the potential for something to happen. And it doesn't have to be every user who has those extra authorities to be a problem. It only takes one user to make that a problem. When we look at the systems as far as how users can get to them, we see every average of this last year, 62 profiles with default passwords. And if you don't know what a default password is, it's essentially username and password is the same, right? So that combination of authorities, default passwords makes for users that can absolutely be problematic from a security perspective, and their pervasive access to the system could be potentially exploited. And when we assume that these people that have worked for us for a very long time aren't going to do things that are inappropriate, but we don't really know what goes on at home for everybody, what's in people's heads. A lot of different things can drive you to do things that are inappropriate, and having too much access makes it easy to take advantage of. I like to share a story I had when I talk about someone exploiting that you don't expect. I actually had traveling before the big uh, global pandemic. Um, I was in an airport in a line at a coffee shop, and I had a couple gentlemen sitting in front of me, and they were talking about somebody who had left the company. They obviously were coworkers, and the one guy's telling the other guy, "Yeah, so apparently." He downloaded the entire customer database and took it to his new job. The other guy was horrified that this guy would do that. And I sat there and I'm thinking, well, yeah, he did because he was allowed to. He was granted access and he was given that ability to go do that. And it's a problem. We need to think about that. And one small breach can actually expose your critical systems. Most cases, if you guys are here, your IBMI is your core server. This is really where the problem lies, is that it, again, one person only takes one thing to be a problem and it can expose it. So that least privilege is where we're going to be able to limit that risk of somebody taking advantage of what they have access to, even though we don't expect them to. And that's going to reduce that impact. So let's talk a little bit about the authorities on the IFS, right? So this is really focused on the IFS. Unique authorities there that may have some contention. I don't know if I want to go rounds with it. I'm not going to get super deep into the weeds. I'm not trying to teach you guys how to do all of this today, but giving you things and directions to go so that you know what you need to do for the future. All right, so object authority and data authority. Two different things. Every IBMI object on the system has both of these. Their data authorities are going to be read, add, update, delete, and execute. Your object authorities are going to be operational, management, exist, alter, and reference. So those authorities are combined typically into the templates of use, change, all, and exclude. So it makes it easier. So you don't have to think about each of those individual authorities on the data and objects. When we look at data authorities themselves, you've got read, add, update, delete. So if you need read to read the object, you need that add, update, delete to change the object itself, execute to be able to run a program or find an object on the system. So there's your data authorities, right? That coupled with your object authorities, you need that object operational to operate on data itself. Based on those data authorities, you need to object management to move, rename, or work with those permissions. You need object exist to be able to delete, save, or restore the object. an object alter for database authority, and object reference for database authority as well. So it's a whole combination of things here. And I'm just going to say right now, all object overrides all of this. So all of these authorities you can set, I'm going to remind you, all object trumps that. So those those working together explicitly is where you're going to end up with that template, the exclude, use, change, and all, right? Clear as mud. Lots of factors in there. Okay, so when we take that IFS security, that IBMI authorities that we were talking about, we're going to layer on top of that the Unix permissions that are going to come with that, as well as PC properties, right? So we have the clear as mud IBMI authorities, and then you add in the additional functionality that is going to be combined with that. Now, when we looking specifically at IFS objects, that object operational authority, it's actually considered a data authority and not an object authority. So now we've already flipped what we know on authorities on objects with the IFS objects, and now it's a data authority. So again, things are a little bit different in the IFS, so untangling that is definitely a challenge. When we look at the Unix permissions, there's actually no equivalent of all for Unix, which is interesting. So now we're trying to equate that all, and it doesn't. But you still have your use, which is going to provide your read and execute, and it's not going to give you object authorities. And then you've also got the change authority, which is going to be that RWX, which gives you all of your data authorities, but no object authorities, right? So little bit different, but still applies to those IFS objects. And then the PC properties. So the PC properties, I think of it of read-only, that's another layer that can be added to protect. So if you do have shares over your IFS and you do allow users to access those files from a PC through the Windows File Explorer, having those PC properties can protect if an IFS file is actually marked as read-only, it will be effective against all objects. So there are some protections you can put in there. It's kind of a side one because it's only going to apply if that's happening through that Windows File Explorer. And it can actually make it really hard to track down why something isn't, you're not able to do something against a file that you expected. Other things you can do with those PC properties, which are, again, unexpected for the IBMI perspective of authorities, is you can archive a file, you can change the property to hidden, and then it can also be assigned a PC system file. So hidden files, story, this is, and I could save it for later when a further part of the discussion today, but the hidden. I actually had a customer once who had allowed users to map drives to their root directory. And of course, people had too much authority and the authorities hadn't been updated on these directories. And they had got a virus on the computer, and it started changing on the local PC files to property of hidden, and it dropped copies of itself with the original name of the file that looked like the file. So when you clicked on it, it actually launched this worm, further integration, further infiltration, and it ended up hiding, changing all the properties on their files to hidden on the IFS share, and they thought all of their stuff was gone. And we went in, and the only way they could find it was doing additional steps to unhide and show hidden files. And then they had to use a PC to undo. I mean, it was a mess. So these PC properties can definitely be problematic and hard to track down where it was done. And you can actually change these a couple different ways. You've got that change attribute command. You've got your navigator for I properties. You've got your window explorer properties, which is really that net server. And then I don't use this, but it's still possibility as you've got that DOS command window, that attribute command. So things can be changed in ways that are unexpected. So we really have to think about how people can get to it. Now, with all of that in the middle of it and the mix is that they are still objects, they're IBMI objects, and they still have to meet those requirements for the system itself. So in order to delete a stream file, for example, you have to have object exist authority. It's an object authority that is not going to be associated with that RWX, right, from that Unix side of the permissions, and has to be granted separately, or it can be inherited from the directory. So not only of the individual files in the directories have their authorities we need to consider, but also the directory itself. When a new file is created, it's going to obtain those authorities as well. It's a wicked web. It gets extremely complicated, and it's definitely something that needs to be addressed. So figuring out and unraveling how to get this done, we'll be able to give you some ideas, some food for thought here to start working on that. So what we want to do is, batten down those hatches, right? Let's start figuring out what are the things we can do to make this less of an exposure and really ensure that the system's not vulnerable through one of these least understood parts of the system. Everything starts at root, right? I mentioned root. It is one of those directories that is there. It is, you may or may not have user directories that have been created. You're going to have the root directory. You have to be careful with it because it is nested. If you start changing authorities at the root, you can make it very hard to use your system, potentially even impossible. So you have to make sure that as you start working on things, that you are doing one change at a time. And this is how I approach stuff, is make a change. What's the impact? Okay, now let's make the next change. Is everything still working as expected? And make sure you know exactly what you did so that you can work backwards if you need to undo those changes you made, right? I don't want to have, I get a phone call that says, Sandy told us on this webinar that we should do all this stuff. And so I did it. And now nobody can get onto the system. I don't want to hear that. And I have had that happen. And I'll share the story with you here in just a second. So first thing you want to maybe consider is on that root folder. It does ship with public permissions of that RWX and all for the data authority and the object authorities. Consider, again, you're going to test this. You're going to only do this and then back out if it's not working. And might do look at doing the data authority of RX and the object authority of none. So you do not want to set public to exclude on the root folder. This is where I'm talking about. Don't do that. If you set public to exclude, you have excluded everybody from the entire system, right? This is not good. There is some additional security we can add that's going to protect your operating system. There's a better way to do it. Okay, so use caution, and don't allow just by default everybody can write to the root directory. Each directory underneath that is going to need that X authority. If they are going to have need the ability to see the contents of the directory, they're going to need that R. So that RX is where that comes together. And then decide if somebody needs to read or write into the contents of those parent folders as well, right? So this is going to be, you can do this from Navigator. You can do this from the command line as well. So you can work from it that way. One of the things you can do is narrow your user's access, right? We were talking about sharing. If you are sharing, consider instead of having users have access to the roots to drop folder or files in those or create new folders with more files, consider using the home directory and giving users their own directories to work with. So if you've got public X on home, and then public sets exclude for data authority on the user directories, and then give the users their own authority RWX on their own directories, you're going to narrow that scope of where they're available. Okay. So, and this is going to give the user the access to their own directory, but they're not going to be able to see everybody else's. If you're not using the IFS directories for your individual employees, you don't necessarily have to go down this road. You don't have to create those individual directories for your users, but you've got that option. And so narrowing that scope and that exposure is where we're looking for here. All right. So you can, as I mentioned, you can do this through the green screen or navigator interface. So, you've got two different ways to do that. The work authority, change authority, and display authority commands. If you do, you can also do work link and do a 9 next to the directory to look at the authorities. So you can change it that way as well. And when we look at the qsys.lib, so as I mentioned, restricting qsys.lib is recommended for anybody who has access to the root through NetServer. This is giving you direct access to the entire operating system, which again, as I mentioned, is not usually necessary. So there is an authorization list that you can use to control who can access it through NetServer. So if they have that share of root, or if they have access to the integrated file system utility coming through NetServer, we want to make sure that they're not able to get to qsys.lib and pull things from the system, change things from the system. There's a lot of things that can happen with that public authority open. So securing the authorization list is where you can set that public exclude. This is where I've had things go sideways. This is not setting root or qsys.lib to exclude. You're setting the authorization list authority to public exclude. I want to emphasize that. We actually, after an on-site, in-person meeting, we had someone go back to the office and change qsys.lib folder to public exclude instead of changing the authorization list. And true story, nobody could get to the system. They were panicked. They said, well, Sandy said to do that. Oh, I said, no, I didn't. You changed the authorization list to public exclude. Okay, we're protecting the qsys.lib. We're not locking everybody out of qsys.lib. You do have to keep in mind, again, ALLOBJ is going to override that. So if you've got your ALLOBJ users, they're going to be able to access that. All right. Managing your file shares is a big part of this. So not sharing, because they're only going to be limited, then they're going to be limited to what you are actually able to access. If you're not giving people access to the integrated file system utility in ACS, if they don't have access to Navigator, you have limited shares, you're going to narrow that scope, right? So make sure that you're going through, remove unnecessary shares. I have had people tell me, I don't know what that share is for. If you don't know what that share is for, I would maybe try removing it and see who complains about it. You're going to find out real quick who's using it. There are a lot of shares that have been around for decades. Everybody's afraid to change it, but it can potentially be a problem and it can expose the system. I've actually been on calls where people have discovered that they actually have multiple shares of the root directory, different names on those shares. So it didn't look like they were both root, but they were. And so really understanding what's there, make those shares read only. 7.5, NetServer and specific shares can actually be restricted by using an authorization list. So adding more security to those shares is huge. And now with 7.6, you've got a new audit value that is going to give you visibility to when shares are created, shares are deleted. So having the ability to track this is really important. If you're looking at maybe if you're doing in GoNets and looking at your current shares, that's a snapshot in time. If somebody created the share 2 hours ago and removed it 10 minutes later, you're not going to see that unless you guys are at 7.6 and you have that audit value set to actually see that activity. So highly recommend looking into that and then also taking advantage of those authorization lists if you're at 7.5 already. All right, so auditing access as well so that you can actually see when somebody is making changes to those IFS objects, especially the ones that have more sensitive information in them, and really being able to see when there are changes there. Even if somebody's adding something to a specific directory, that might be a red flag or something to watch for. And then for even more visibility to what's happening with your IFS objects, you can actually use exit programs to track what's happening through those net server actions. So when we're looking at the IFS object access, again, the object auditing commands, and then actually getting that all object special authority, make sure that you have enough authorities to start creating those auditing values. Okay, there's a lot of commands that are available on the green screen side of things that are going to allow for somebody to work with the IFS. So again, not just focused on the shares and those non-green screen interfaces, make sure that you are in fact limiting your user's ability to run commands. Limit capability, yes, is your friend and keeping people out of the IFS. And then also auditing the commands and then even potentially changing the authority on those commands. So most of your users probably don't need to be creating directories or removing directories, navigating the system that way. So ensuring that you are gaining control over those commands. There's some others as well that you want to start keeping an eye on. Start auditing the use of the commands, restricting the use of the commands, copy stream file, import file, changing the authority and owners, saving and restore. So a lot of different commands to consider. When we think about the IFS, we're not really thinking about IBMI commands. So, but it all is involved. So when we start looking at, okay, we need to have users that need to be able to do these things, but they don't need to do it all the time. We've relied on with our programs to use adopt authority, but with the IFS, it doesn't actually support authority adoption. So it can be a little bit of a challenge. And so these applications are going to rely on that. So you can do profile switching. So instead of leaving the IFS authorities wide open, instead using an API to switch a profile in the program to a profile that has enough authority, or even use third-party tools like our authority broker. Think of it as the user gets to go into that magic phone booth and come out a superhero, right? Where they're going to have those powers when they switch to the elevated authority, rather than just giving it to them and rather than just leaving those authorities wide open, right? So that's that compromise of, yeah, we need to lock this down, but we still need to use it and leave it available. But we're going to put some controls around it and guardrails on how we're going to get those users there, since we can't use that authority adoption. All right. When we think about IFS security, we've got multiple controls at work, and the security we're relying on is that front gate, right? So we've got the guardrails here where we've got that sign on, we've got the application controls when you're thinking about the green screen. So your security is relying on somebody coming through the front door. And with those public permissions and private authorities to give users access, and users that have too much authority on the system, and the fact that there are alternative ways to get to the system, they're bypassing those security controls. And really what we need to start thinking about is, how are you going to ensure that someone's not going to be able to just simply bypass the controls you have in place, even on the green screen. If your users don't have that limit capability, yes, that security on that application menu that we're relying on can be bypassed. And users can be able to get the command line. If they have those special authorities, they're going to be able to take advantage of that. So those are really the things where we have to start considering. Multiple controls are at work here, and we have to create that balance and make sure that we are addressing all of the potential ways that our security could be breached and taken advantage of. This is where exit programs come in. These are really set to think as it as the security cameras over all of those entry points to the system, where we can actually, you can have it set to actually stop a user if they're coming in through a doorway or an entrance that they're not supposed to. And it's going to be really effective against inappropriate actions against your file server in the IFS, right? So IFS files are going to be populated on the system, multiple interfaces. You've got your file server, you've got your FTP uploading files that way. And of course, I'm going to talk a little bit more about where things can come from and why we need to be concerned about that. But using an exit program is really going to give you visibility to who's going around those security controls you have on the front door to the system, and give you the ability to start putting in those guardrails, those, hey, yes, this user can do this, but not that. And really being able to put those restrictions there. So it does make it straightforward. So those IFS exit points, you're going to be able to put those controls in place and supplement what you already did with locking down security. So restricting based on which door they use, if they can change those file attributes, if they can delete those files, are they allowed to move files through that particular interface? And that's where an exit program is going to be able to restrict that. It is effective against all object users as well, because an exit program is at the door to the system. It's going to apply the restrictions before the user gets to their system level authorities. So you can narrow somebody's access based on what door they come through. So it's extremely valuable in saying, yeah, we have our IFS locked down as much as we can, but we're going to put these controls in place that say, yeah, if you come through this door, you don't get to it, right? So really allowing you to do that. Example here, this is from our exit point manager, where you can actually restrict, as you can see here, access to a specific directory, right? So this is Bob trying to access the HR directory. He got rejected because we've said he's not allowed to get to that, even though the public authority might be wide open on that directory, probably not, but Bob might even have that all object, but I've restricted him through the file server so he doesn't get in, right? So this is where you're going to have that visibility. Where is he coming from? Wait, that IP address there, that's not Bob's IP address. Who's using Bob's credentials and why are they trying to get to this directory, right? So really giving you that visibility and control over who can get to the IFS, how they can get to the IFS, and what they're going to be able to do, and where they're able to come from to do that, right? So really trying to corral and contain how we're getting to the IFS and potentially the entire system, right? With that root directory, that qsys.lib, this could be a pretty big exposure if somebody can get to that without you even being able to see it. All right, so user activities, right? So we've talked a lot about that, what people could potentially do. We also have to consider malware. And I know it's the eye roll. Sandy's always talking about malware. Well, the reason I do that is because it's a problem and it's not going away, right? So that virus threat, oh, well, viruses are old. That doesn't happen anymore. It does. It still happens. We have layers of protection in our networks, but you can never rely on a single layer to protect yourself. So the IBMI itself can act as a source of infection in a network, users accessing those files. You're going to have your PC protections. Well, that gets disabled because I know people who will disable their defenses on their system because they're trying to do things and they keep getting blocked and they're frustrated. So they say no. Or you have a workstation that hasn't been updated in a while. That's how things get there. that malicious code, while it can sit there natively, it doesn't necessarily, the system may not look like that's infected. So it doesn't show signs of being infected, but it can be impacted. And if you guys have, malware can change native objects as well. So important to secure that qsys.lib and not share that root is that native objects like qsys.lib, if that user has the ability to delete the malware that's taking advantage of their authority, can delete things as well, and it can impact that native file system. Malware can get onto the systems through a whole slew of ways. We were talking about map drives, but it's not the only way. Those shares that we were talking about, files can be FTP to the system. Another great use case for having an exit program. Who's putting stuff on our system through FTP? We should see that, right? Third-party installs, image catalogs, NFS mounts. If you have access to other servers, right? We were talking about integrated file system, and allows you to integrate with other operating systems. Well, those other operating systems have malware problems. So all that does is allow it to come back to our systems. HA systems, guess what? If you get an infection or malware on your production system, it's going to replicate to your HA system. Okay, that's a problem. Restored backups, right? So how far back do you need to go before you have a clean copy of these files? So it can spread to and from the system. And we were talking about what's in the IFS, web files, right? You guys probably have GUI or web interfaces that's using the IFS. If one of those files is infected, has redirecting traffic, we've seen web shells on customer systems where it can create a backdoor to the system through that web shell. So there are things that can get spread. The rise and the further use and expansion of open source. There was a problem with GitHub not too long ago that there were some problems with some of the applications on there. You're loading open source on the system into your IFS for those web interfaces. Are you evaluating them before you put them on the system? You need to think about that. The system itself is just a couple steps away from the rest of the globe. Or you may have a system externally facing. Most likely your system's behind the firewall, but you have given people access. But those people that have access while they're inside of your firewall, they have access outside the firewall. So it creates that potential for things to happen. So what we really want to do is make sure that we're scanning the system and that we are able to clean these files. So making sure the system's not hosting it, that's not being part of an outbreak. Ransomware attacks are huge. We all know about those. The money's gone down on those, but they have continued the attacks, and they're focusing on small to medium businesses because they know that they don't have the resources that those large corporations do. And so that's where that target is. So using the infrastructure that IBM provides, you can scan natively. There's a couple system values, there's a couple of exit points and attributes on your files. All those stream files and all those directories have attributes related to scanning so that you can actually do that scanning natively. You can do it on access. So as people open the files, you can also do anti-ransomware functionality where you're able to monitor behavior of users coming through the file server. And if it looks like malicious behavior, typical ransomware attack, you can block the user, right? So this is about protecting the system and making sure that malware is not on it. I have horror stories from infections I've seen, and I am always happy to talk about them. Some of them have been catastrophic. Some of them are small, but it's still never good practice to have malware on your core server. Just not good. So sometimes the challenge there, say, all right, well, let's just scan from maybe a Windows server. Let's do it that way. Unfortunately, this is actually creating problems. This is going to actually, you're going to have to share the root, which I already said, don't do that. You're going to have to use an all object profile in order for that scan to run. Not only does the profile that has to scan need all object, they're also going to need secadmin because there's a quirk with the IFS that requires that secadmin in order to navigate the directory structure for some reason. I'd have to go back and dig in to see what that was, but I've always kind of scratched my head on that one. Network bandwidth can be a problem. You're actually dragging all your objects across to that Windows server. So really scanning from the network from a non-native is going to be problematic. Essentially you've gone from, yeah, it's isolated onto our system. Now we're going to add fuel to the fire. We're going to actually take that and expand it, give the access we needed to remove, and it's just going to, it's not a good way to approach it. So native scanning is really where you should be doing that. All right, so lots of things to think about. When we look at it, the IBMI is really a perfect storm for a disaster. And, we're very proud of our power systems. IBMI is so reliable, so flexible, so integratable, right? But we find that security on IBMI, it's not, people don't have time for it. You don't have, and you're not able to invest in the time, the training, all of these things. So with the knowledge less, audit professionals don't know to ask the right questions, and truly audit requirements, those are the basics. That's not the making the best effort to secure. It's saying this is the minimum effort that we put in. And then we also have that on top of that, that the power systems, the IBMI systems really have most likely some of the most valuable data for the company. And with that data not secured properly, users having too much access, and it's really easily accessed through those PC interfaces, we have that potential for some really big disasters. And, it's concerning. So each thing that you can do to start reducing and pulling down those exposures, the better. So how are we going to do that? Right. So all those things that we just talked about, looking at the security, you guys are sitting here. You're actually looking at security and talking about it and attending a webinar about security on IBMI. So that's helpful, right? So you're gaining awareness, you're gaining a little bit of knowledge. So what we're going to do is, what I want you guys to do is think about figuring out what applications are using your IFS, right? How is your IFS being accessed? Exit programs will give you that visibility. Make sure that you do that homework on how that security works with the IFS. As I mentioned, be cautious, be careful with it, one change at a time. Definitely address any root shares, look at your home directories, make sure that your qsys.lib is secured properly with that authorization list. Monitor and protect your file shares, right? Make them read only. You can also make them so that they're not discoverable on the network. That again will also reduce that potential of them being found and taken advantage of. The auditing and alerting on what people are doing is going to be critical. Auditing all those commands we talked about, using an exit program to see who's trying to delete files in the IFS through one of those non-green screen interfaces, scanning for malware, and then test it, right? You've got to make sure that once you've done all these things, go back and make sure that the steps that you performed are in fact doing what you expected, right? You can all day long say, yeah, I did all these things. And then if you overlook one step, you don't test it, you could actually leave it and have a false sense of security. So, all right, lots of stuff to think about. And again, as I said, clear as mud, right? All of those authorities, the object and data authorities, combined with the PC authorities and the Unix permissions, all of that together is definitely Pandora's box, rat's nest, whatever you want to call it. But it's something that needs to be considered. And taking a good first step is, potentially looking at doing a security scan. We have a free tool from Fortra here that gives you the ability to evaluate at a high level your current security posture on a system so that you can actually see, do I have a bunch of users with all those special authorities we were talking about? What's the default authorities on our libraries? Do we have exit programs registered so we can actually see what's happening? Are we auditing all that activity? So lots of things that can give you a good starting point of, hey, we need to pay attention to security on the system. So I like it. It's a really good way to do a level set of where you are starting. These systems have been around for 30, 40, 50 years, longer, not 50 years. No, not 50 years. So they're going to be, 40 years, right? And the security's been assumed all along, and we need to really start looking at it. So invite you to do that. This is definitely an ongoing conversation you should be having internally and with all of the IBMI security experts out there. I'm not by far the most prominent one. There's a ton of people who are going to be able to give you some information about. All right. Really appreciate everybody today. We've had a pretty good crowd here, and I love that. I'm always excited to share information. Hopefully, it doesn't make it even more confusing. Looks like we do have a couple of questions, Peter.
Yep. So we do have two questions right now. As a reminder for anyone that is here today, please go ahead and use the Q&A area in Zoom for any questions, and we can go ahead and get Sandy to answer those. So the
Yeah.
so the first one is from Roger, and that is, how can you see a hidden file?
Yeah, so with the hidden file, there's actually, you can do it two ways. You can do from a PC, if it is a share, you can do a right click and do properties on the directory, and you can actually check a box to show hidden files that way. You can also, on the work link command, when you do a work link, prompt it, and you might have to hit F9 or F10 to get the rest of the parameters up, but you can select on that work link command to display hidden files. So it is not by default going to show hidden files, but that is an easy way to get to that.
Perfect. Thanks, Sandy.
Yeah.
And for this next one, I'm going to be upfront with you. I am going to say something wrong. I can promise you right now. So this one is from an anonymous attendee, and it says, if you use PowerTech exit points and have asterisk file SRV user asterisk public with authority of asterisk reject, that locks doors for users to get to root even though they might not have IFS root folder marked correctly. Is that right?
Yes. Okay. So I have to, in my head, I'm going to unwind that there a little bit. So I think what this means, and correct me if I'm wrong, that you can drop it again in the chat. So if root is shared as something else other than root, is what I think this means. If it we don't with exit point manager on the file server, if you have the public set to reject, they're not going to be able to get to the IFS through the file server, regardless of what the share is called. So that would actually lock them down. So
All right, perfect. Thank you. And again, if you have any corrections in terms of understanding, just go ahead and put that in the Q&A area.
yeah.
This one is coming from Christopher. Is there a happy path in tracking down permission inheritance issues? For example, an IFS folder where users have permission RWX. Then our application places files in the folder for users to receive, but the created files present with R, no WX.
Mm, okay. So I would look at the folder itself to see if there's a create attribute. on the folder where the files placed will inherit the folder permission. So that's where I would start. Again, do a work link and navigate to the folder itself, and then look at the attributes, see what it says on that. And I'm just off the top of my head, there's so many parameters. If you go look at the attributes on the IFS files, there are so many of them. But that's where I would start. I think that's going to be your best route. Um, if not, yeah, I think that's probably where it's coming from. Either that or the application profile may not have authority. That might be an option too. So I would start with the work link though, again, and look at that the attributes on the IFS folder. Make sure that when you create objects, it's going to use the authorities of the IFS directory. And then to change the attributes, use the change attribute command, plug in the directory name, and then specify which attribute you're changing. So hopefully that helped. I feel like there's nothing happy with the path and the IFS permissions. That's why we have so many sessions at Common, Power Up, and Navigate on IFS security, because it's a wicked, wicked web. So
Yeah, so I guess one thing that I have for you, I don't see any other questions, so if anyone does have any additional questions, go ahead and use the Q&A area. Have you noticed any questions popping up as you've done your IFS sessions that really just come back on a really common basis, that you really just find yourself answering those same types of questions a lot?
yeah, and it's always around the malware, because it's I don't we don't allow users to map drives. And it's this perception. I think it started early on that you had to map a drive to have that cross contamination from users to the IFS. And it's probably the most common one. Um, I get into conversations about PowerTech antivirus and ransomware functionalities and stuff. They're like, oh, my users can't get to it. I'm like, they can, they're using it. So it's ongoing. And the more education we can do and the more we talk about it and the more we try to give nudges in those directions, the better.
And I guess there's another follow-up question for you. Do you have any resources that you would recommend individuals to look at that are very helpful when working with the IFS directly?
Yeah, so there are, I mean, you guys, Common, you guys have a bunch of educational stuff, videos on your website. We've got education on our power.fortra.com website with information there. We've got you've got your in-person sessions, a lot of on-demand webinars. We have professional services, security services. They can help. I mean, there's a ton of resources out there. You just have to do a little digging. I think between all of us, we've got a lot of information available. So
I definitely agree. And so I don't see any additional questions. Do you have any last words that you want to say to the audience before we go ahead and start to break up the PowerCast?
do something, anything with your security. If it's one thing, you're better than you were yesterday. Just being willing to actually do it. And I'm so thankful that everybody's willing to sit and listen to me talk about it. Hopefully, you take action.
Perfect. Thank you. So once again, I just want to thank Sandy for the very thorough presentation, for the rest of you for taking some time out of your busy day for an hour of education. This event will be available by end of day Friday in the Common Learning Management System. Thank you everyone very much for being here today and have a great rest of your day.
Thank you, Peter.